Hello everybody and welcome to another YouTube video. So in today's video, I'm going to be showing you how we can create some fractal art using Python and the Turtle module. Now specifically, we'll be using Recursion to actually create these fractals. And well, in case you're unfamiliar with what fractals are, let me just show you a really quick example here of what we're actually going to create in this video. Now what I'm showing you here is really just scratching the surface of what's possible with this kind of method of drawing things and creating these types of patterns. You can get really creative with this. I actually remember back when I was in about grade 11, I think, this was given to us as a school project and we had to create fractal art. And I remember people came up with all kinds of really interesting stuff that uses this kind of method of repeating a pattern over and over again, or repeating a series of steps over and over again, to create a pattern or a fractal like this. So fractals are a pretty hard thing to define, but really, as I was saying, you're kind of repeating a series of steps and that ends up creating an infinite pattern that kind of looks really interesting and cool. In a lot of abstract art, you'll see stuff that kind of looks like fractals or may resemble a fractal. And well, here you can see we have a snowflake and we have a tree. These are the two things I'll show you how to create here. But as I was saying, you can kind of go and extend this and modify these and create some really interesting fractals with this method. So with that said, let's dive into the video after a quick word from our sponsor. Before we dive in, I need to thank Typing DNA for sponsoring this video. Typing DNA uses typing biometrics to verify users' identities and provide a seamless two-factor authentication method. Typing DNA helps you avoid annoying and unnecessary SMS authentication messages and only uses SMS and email verification as the root of trust, not the default authentication method. Not only are typing biometrics convenient, but they're also secure. Typing DNA uses proprietary typing biometrics authentication technology coupled with key phrases of high complexity regarding the number of different characters, the way they are dispersed throughout the keyboard layout, and the vertical and horizontal travel. One of the best parts of Typing DNA is that it's free and also extremely easy to implement. Start using Typing DNA and typing biometrics today to provide a better experience and seamless authentication method for your users. Check it out from the link in the description and create an account to try out the demo you see here. Alright, so let's just go ahead and dive in here. The first thing I'm going to show you is just a little bit about the Turtle module, so kind of a little summary about that, just show you some of the methods and functions that we're going to use here. Then I will show you how we can build the tree, and then how we can make the snowflake. Now, the first thing we need to do here is we need to use the Turtle module, or we need to import the Turtle module. So I'm going to say from Turtle, import asterisk or import star. What this will do is import everything from the Turtle module so that we can use all of the methods without having to prefix them with turtle dot and then whatever else. Now, I realize I haven't really explained what the Turtle module is. So this is a 2D graphics module in Python, allows you to make very simple kind of art, I guess you could call it, or illustrate things or kind of visualize things. Usually this module is meant for kind of beginners or intermediates, but you can make a lot of cool stuff with it. Super simple. It's built into Python by default. You don't need to install it. And I actually have an entire tutorial series on my channel showing you how to use the Turtle module. So if you want to follow along with that, if some of this stuff is confusing and you want, I guess, some information about it beforehand, feel free to check that out. I'll leave a link to it in the description and put a card to it in the top right-hand corner of the video. Okay, so from Turtle, import star. Now what I want to do is just give you a quick summary of how the Turtle module works. The first thing that we need to do here is we just need to type main loop. Now the reason we need to type this is because what this will do is make it so the Turtle module screen or kind of canvas doesn't close immediately as soon as we run the program. Because right now, if we run the program, what's going to happen is we're going to import everything from Turtle, and then we're immediately going to end the program. So when you put main loop here, this will make it so that we kind of stay in the program until we press the X button on the Turtle screen. So if I run my program now, you can see that there's a little X, and now when I press X, obviously it closes. Now, one last thing I'll note, because I'm sure some of you guys will ask, I'm using Sublime Text here. This is a free text editor. You can use this if you want, but really the only prerequisites for this video are you have Python installed and you have some text editor you want to use. You could use the default IDLE that comes with Python, or you can use whatever one you're comfortable with. All right, so now we have main loop. Okay, so when we do main loop, you can see it pops up the canvas there, and that's where we're actually going to be kind of drawing stuff. Now, the reason this module is called Turtle is because you have this little, I don't even know what to call it, kind of pointer, cursor. Cursor is probably a better word for it. And the cursor starts at 0, 0 in the very middle of the canvas. And then you move the cursor around, and every time you move it, it's going to draw a line based on where you move it. So the best way for me to show you this to you is to just move the cursor forward by a certain number of pixels. So the first method that I'm introducing here is called forward. It takes a number of pixels. You do forward, number of pixels, and then it's going to move your cursor forward that number of pixels. Now notice how this isn't a turtle, but you can actually change this to be a turtle. In fact, I'll show you how you do that. If you do shape and then turtle like this, there's a few other ones as well. And then you run this, notice now this changes to a turtle, hence the name of the module. Regardless though, you saw it starts facing right. It starts at 0, 0. So the directions or the coordinate system of turtle is the middle is 0, 0. As you go up, the y increases. As you go down, the y decreases. As you go to the left, the x decreases. As you go to the right, the x increases. So it starts facing the right. When you go forward, it's going to move to the right. Okay, so now I'll show you how we can change the direction of the cursor head. So if you wanted to, say, turn this turtle so it's going to the left, what you could do is say left 90, and what this will do is relative to the current position it's facing, it will turn the cursor 90 degrees to the left. So if I do this, and then I say forward 100 like that, see how we go here, then we make a right angled turn, and we go left, and we go forward by 100, because what we had left 90, forward 100. Now you don't have to do them on right angles, you could do 45 degrees. If you do this, notice we turn 45 degrees, and then we go there. All right, so that is kind of the basics. Now, in the same sense that there's left, there's also right. So maybe we go right by 90 after we go left 45, and then we go forward by another 100. There you go. You can see we've kind of created the top of a triangle here. Nice. Now, another method to show you is backward. So you can also go backwards in the same way you can go forwards, right? So I don't think I need to explain what that does. You can see that now it goes back. Nice. Now, there's a bunch of other methods. I'll kind of get to them as we go through here, but that's the very basics. Just wanted to give you a quick, kind of explanation of what's going on here and what we're doing. All right, so now that we have that, what I'm going to do is I'm going to leave the shape equal to turtle, but I want to change the speed of this. So when you set the speed equal to 0, and actually let me go back to what we had before so I can show you, what this will do is make the turtle as fast as possible. Now, since we're going to be drawing a lot of stuff, it's a good idea to do that. Otherwise, it's going to take a long time. So notice I had speed equal to 0, and this happened almost instantly, obviously because it's very fast now. Nice. Okay, so now that we have our shape equal to our turtle and speed equal to 0, what we can do is start drawing the tree. So let's get into that part of the video. I'm going to create a function here, and I'm going to call this tree. And what I want to take for this tree is the size of it, the number of levels in this tree, and then the angle at which all of the branches should be in this tree. So let me just run my previous example here so we can kind of look at the tree that's created, and then I'll discuss exactly how we're going to go about making this using recursion. So notice here that we kind of have a lot of different levels in this tree, right? We have our first level, which is these two branches where my mouse is, so just these two ones here. Then off of each of those branches, there's two more, right? And then off of all of those branches, there's two more. And that's kind of where the recursive aspect comes in here. Every time we draw a branch, we're going to draw two more at the end of that branch until we reach the number of levels that we specified for this tree. Now, I believe the number of levels for this tree is 6. It's either 5 or 6. We have 1, 2, 3, 4, 5. Okay, so there's 5 levels in this tree. This first line doesn't count as a level. And anyways, that's what a tree of 5 levels looks like. But as you increase the number of levels, you increase the number of branches, and obviously the tree gets larger and more complex. Nice, so that's kind of the basics. So what we want to do is want to go up, want to draw a branch to the left, draw a branch to the right, and then off of all of those branches, same thing, left, right, so on and so forth. But how do we actually do that? Well, when we go up, we need to determine what direction we want to turn the turtle to the right, so at what angle. Then we need to turn it back to the other side to draw the other branch. Then we need to draw both of the branches off of those. So I'm going to show you how we go about doing that, but I just wanted to kind of give you an example here so you can see what it is we're going to be trying to create, because it is pretty abstract when I start writing a lot of this stuff. So the first thing I need to do here is, since this is going to be a recursive function, we're going to call this function from inside of itself, is I need to define a base case, essentially telling this function, hey, when do I stop? When am I allowed to stop recursively calling myself? You need a base case. If you don't have a base case, you're going to run into an infinite loop, and you'll have some error pop up saying maximum recursion depth exceeded. If you see that, that means you didn't implement a base case and your function just never stops running. So what I'm going to do here is say if the levels are equal to 0, then what I want to do is return. And the reason I'm going to do this is because what's going to happen is I'm going to call this function. I'm going to pass it some size, let's say 90. I'll pass it levels, maybe like 6, and then we'll pass some angle, let's just say 60 degrees. And inside of this function, we're going to call itself. But every time we call ourself, we're going to say with the size, levels -1, and then the angle. Now, forget about this first and last parameter. What you want to look at is this levels parameter here. Every single time we recall ourselves, we're going to subtract 1 from levels. So eventually we're going to get to a point where we have levels equal to 0. We reach our base case, and then we move on with the rest of the program. Hopefully that makes sense, but just trying to give you some explanation here in case you haven't seen recursion a lot before. Okay, so let's keep going here. The first thing I want to do inside of this function is I want to go forward by whatever the size of the tree is. So this will be responsible for drawing that very first line. We saw that first up vertical line, but this will also draw all of the branches as well. This is actually going to be the, is this the only forward that we have? Yes, this is actually the only forward that we have, because every single time we get to a point where we're drawing forward, we're ready to actually draw a branch. And by the way, if you see me looking over here, I just have another screen open that has the code for this so I don't forget, because it's very easy to mess this up. There's a lot of stuff that needs to be pretty specific. All right, so we're going to go forward by the size of the tree. And then once we've drawn our current branch, what we want to do is draw 2 more branches, one to the left and one to the right. So what we're going to do is we're going to go to the right by whatever our angle is, and we're going to draw another branch. Now, to draw a branch, we're going to call this tree function, because inside of the tree function, we have this forward, and then it will draw more branches, right? So we're going to call tree. But this time when we call tree, we're going to pass size multiplied by 0.8. So pretty much we want to pass 80% of whatever the current size was to be the length or the size of the next tree branch, so that they actually get smaller, right? And it makes sense. And then for levels, we're going to say levels minus 1, because at this point we would have already drawn 1 level. And so now we're passing levels minus 1 to indicate, hey, now when you go to the next step, we're going to be at, 5 levels left to draw, 4 levels left to draw, so on and so forth. And then for the angle, we're just going to always pass the same angle. Unless you want to tweak this, feel free to, multiply it by a random number or something, and you'll see kind of different angled branches, which is always interesting to do. Maybe we'll do that at the end. Okay, so we have tree, size times 0.8, levels minus 1, angle. That is going to draw our right tree branch. Now we want to draw the left tree branch. So to do that, we need to go to the left. So we're going to say left, and we're going to go to the left by angle multiplied by 2. Now, the reason we're multiplying the angle by 2 is because if we just went to the right by our angle, so imagine we're straight up. If we went to the right by some angle, I know that's your left, but that's my right, then if we want to get back to the middle, we would have to go the opposite direction by the same angle. So if this is 60 degrees and we want to go back to the middle, we have to go back 60 degrees. So if we want to go to the other side by the additional amount of the angle, we need to go 2 times the angle. So from here, 2 times the angle brings us over there. Hopefully that kind of makes sense. I'm sure the hand gestures are a weird way to visualize this, but that's why we need angle times 2. I can actually show you what happens if we don't do that, but angle times 2 is correct. Okay, so now we've gone left. What we need to do is draw the other tree branch. So we're going to say tree, same thing. We'll say size multiplied by 0.8, levels minus 1, and then angle. Okay, and then what we want to do is we want to go to the right by our angle. The reason we're doing this is because we're going to straighten ourselves back up now. So we've gone to the right by the angle, we've gone to the left by 2 times the angle, and now we're going to the right by the angle. So now we're right back in the middle. That's kind of where our head is. And then we are going to go backwards so that our turtle goes back to where it started from. So you'll see why we need this in a second. We're going to say backward and then by the size. Because we went forward by the size, right? Then we turned right. Then we drew the next tree branch. This, when we have this recursive call here, is going to draw the entire right subtree. And then what we're going to do is go to the left, draw out the entire left subtree. Then we're going to straighten ourselves back out, and we're going to come back. Now, at this point in time, this will actually work. I'm just going to show you what this looks like so that we can see what we've done, and then I'll explain exactly how this works. So let's draw a tree. We just write tree. Size, give it whatever you want. I'm going to give it 70. Levels, I'd recommend you go with something like under 8. If you go 8 or above, it's just going to take a really long time to draw. And then angle, 60 is a good angle, but you can go with any angle that you'd like. But I would recommend making it above 20. Otherwise, you're going to see a very kind of squished tree. Anyways, let's just run this and let's see what we've done here. So notice that when I do this, we get this kind of strange looking tree, right? And it's even more weird looking because of the fact that it is sideways. So what I'm going to show you how to do now is turn it to the left. So the first thing we're going to do before we even draw the tree is we're just going to go left 90 degrees. So left 90. So now when we actually draw the tree, it doesn't look quite as strange. So there you go, we got a tree. Now the reason this looks so weird is because the angle we gave here was 60 degrees. And so at every single kind of point where we need to draw another branch, we were going off by 60 degrees. And so here you can see this is a 120 degree angle because, well, 60 times 2, right? And so if we want to make this look a little bit more normal, we can decrease the angle and make that something like 30. And now we can see that this tree is looking a bit more as we would expect, right? That is really how you go about drawing the tree. Now I'm just going to change the speed here so that it's 1, so it's the slowest it can possibly be, so we can actually see what goes on here. So notice we went up, we went right, we went right, we went right, we went right, then we went back, then we went left, then we went back, then we went left, right? Then we went right, left, then we went back. Just kind of watch what goes on here as we draw this tree. It draws the branch, then it returns back to its original position, then it draws the other side. It draws that other branch. And that's why we had that backwards there. And then notice once we get here, it goes all the way back to the very beginning. The reason why we needed this, right? The reason why we needed it backward is so that we return back to the original position before we try to draw the next branch. Because if we don't do that, if I don't include this backward here, watch what happens. You're going to see we get a very strange looking tree that kind of just goes off in random directions, right? Because we're not returning back to the point where we were going to draw that next branch. And so that's why we need the backwards there. And same thing with, left angle times 2. If I don't have times 2 and I run this, you're going to see what happens. We get something that looks like this. Again, a very kind of strange looking thing. If you actually run this, you'll notice this pattern does kind of repeat and it makes something that looks, somewhat interesting. But obviously that's not a tree. That's not what we wanted. Okay, I'm going to stop running that. All right, so hopefully that kind of explained why we need the backward. Recursion is a very difficult thing to explain, especially when you have a lot of different calls. But let's just run through this to make sure it's super clear. So we have tree, right? We're taking size, levels, angle. Obviously, we understand the base case. If levels equal to 0, then we're not doing anything. We will do something in a second to have those little green bubbles, but skip that for now. All right, so then inside of this, the first thing we do is we go forward by whatever the size of our branch is. This is good because this means that after we go right, and after we call this tree function again, we immediately draw the branch that we had wanted to draw, right? We called tree, and then we're already angled the right direction. So we just go forward by whatever the size was that was passed this function, and we draw that first branch. That's why that first one is vertical, because the first thing we do here is we just go straight up and we draw that branch. Okay, then we turn to the right. This is so that we can draw the right subtree. So all of the right subtree. Now, once we hit this function here, what happens is we go back up here, right? We go back into this recursive function. So now we're calling with size times 0.8, so 80% the size, 1 less level, and the same angle. Now, we're already turned to the right because in the previous step, we had turned to the right. So the first thing we do is we go forward, right? And then we turn right again. So we angle by 30 degrees, and then we call this recursive function, and we draw the right subtree of the right subtree. Hopefully that makes sense, but we draw the right subtree of the right subtree. Then we get back into this function, right? So now we go forward again. We're already angled the right way. We go forward, we turn right, and then we draw the right subtree of the right subtree of the right subtree. And this repeats until obviously we get through all of the levels. Now, as soon as we're at the point where levels is equal to 0, what that means is the function that called this, we can now go to the next step because we've got through all of the recursive calls. So now we go to the next step and we say, okay, well, we had turned right by a ton. So now we need to turn left by the angle times 2 to draw the left subtree of whatever function just finished. So then we go back, we return to the left, and then we draw the left subtree. And now the process repeats here, except with the left subtree. So now we draw the left subtree. So we come back up here, we say is levels equal to 0? No, it's not. So we go forward in whatever the direction was that we were pointed. Then we turn to the right and we draw the right subtree of the left subtree. And then we continue and continue and continue and continue. And eventually we get to a point where we have drawn the left subtree of some left subtree, and now levels is equal to 0. So as soon as we get to the point where this function is done and we return to wherever this was called from, now we turn right. So we go back straight, right? And then we go backwards and we return back to the original position that we were at. So again, the reason we need this is because remember in the first step here, we went forward. So after we do all of this stuff, we need to go backwards to make sure we go back to where we started from. So then when we draw the next subtree, we're not drawing it from the end of the right subtree that corresponds with the left subtree. We're drawing it from kind of the origin of where this function was called from. This is very confusing, obviously, to explain, but if you do this in the very slow speed, you can kind of see how this works and why we actually get the tree that we do. Okay, perfect. So I'm going to change the speed back to 0 here. Unfortunately, that's the best explanation I can give you. Let me know in the comments if that was sufficient. But what I'm going to show you now is how we can actually draw those kind of green little bubbles, right? So what I'm going to do here is I'm going to change the color of my turtle to be green. So you say color, put it in a color. There's some preset ones. One of them is green. So we do in a string green. That changes the color of our cursor to green. Then what we can do is say dot. What we can actually do here is we can pass whatever the size is that we're currently on. So when we get to the last level, and we will make a green dot with the radius of this size. So we can do that. And then we can say color, and we can make this black. All right. So now if we run this, you're going to notice that as soon as we get to the point where we're at the end of our branch, so we reach our base case, we do that little dot, right? And I just want to show you what happens when I increase the number of levels. So instead of 5, I go to 7. So now when I go to 7, notice how we're going to get a more complex tree. And obviously you guys are welcome to mess around with whatever number of levels that you want and change the angle. And maybe you can implement some type of random stuff in here, change the color of the branches. Go ham, do whatever you'd like. I'm just showing you kind of the basic one, and you guys can extend and add on from that. But there you go, a beautiful tree. Nice. Okay, now we have that. Let's do the snowflake. Now the snowflake is, I don't want to say more complicated, but it's very different how we draw the snowflake. So let me just run that previous program here so we can actually have a look at this snowflake. And actually, sorry, I'm just going to change this so that's a little bit of a more simple example so that we can have a better look at how this works. So I'm just looking at my other script here. Bear with me. Okay, let's run this. There you go. That's what I want to look at. Okay, so ignore the tree. Just look at the snowflake for now and see if you can kind of pick up the pattern that's going on here. Now, it's fairly obvious, but this has to do with triangles. So the way that this snowflake is actually going to work is we are going to draw 3 sides of the triangle. So the first side is going to go from where this red cursor is to where my mouse is. The second side will go from where my mouse is to kind of this point right here. And then the third side will go from my mouse to this cursor here. So we're going to draw 3 sides. All 3 of these sides will be generated with the recursive function, and we'll kind of connect them together in the sense of a triangle, right? Drawing 3 sides of the triangle. Now, the way this recursive function is going to work is it's going to draw one of these sides. And in fact, let me show you what happens when I draw just one side so you can kind of see what it looks like. All right, so this is what one side of our snowflake looks like. Now, as I was saying, we're going to connect 3 sides together in kind of a triangle form. So we'll connect the sides at 60-degree angles so that it creates the snowflake. But just examine and kind of look at this pattern here, and I'll show you obviously how we make this. But the way it works is we draw one small triangle, we draw one large triangle, and then one small triangle. But on the large triangle, we draw smaller triangles. And this large triangle is comprised of smaller triangles. The way it works is we have these 3 small triangles making up this one larger one. And so this is with a depth of 2. Now watch what happens when I change the depth here to be 1. So when I change the depth to be 1, notice how we just do one large triangle, right? And now if I change the depth to be 3, what happens is we have a bunch of triangles, right? So we've kind of replicated that smaller side you saw. So with the depth of 2, we put those on both sides, and then we have one kind of larger triangle with a bunch of triangles on top of it in the middle. So that's kind of the way this works. I'm just going to walk you through the process of making this, and then obviously we can run it, we can see what it looks like, and I can explain how this works. But that's kind of the pattern there. So we draw one of those sides. Once we can figure out how to do one side, it's pretty easy to connect them together, and we can connect, a bunch of different sides together. It doesn't just have to be 3 sides. Okay, so we have all of this stuff for tree. What I'm going to do is make another function here, and I'll just call this snowflake, like that. And actually, in fact, this function is going to be called create snowflake because we're going to have 2 functions, one that will create the snowflake side and one that actually creates the snowflake as a whole. So inside of this create snowflake function, I'm not going to do anything for right now. I'm going to start by just making my snowflake function. Really, this will be a snowflake side. So the snowflake side function, what this is going to take is a length and again, the number of levels that we want to have, or kind of the depth, I guess we could say, we'll leave it as levels for this side. So inside of here, same thing as before. In our base case, we're going to say if levels is equal to 0, then what we're going to do is return. But before we do that, we're going to go forward by the length. Now, this is a little bit different than what we did inside of this tree function here, where we started by going forward. Here, we're going to end by going forward. Now, you'll see how this works in a minute. but just kind of bear with me. So I'm going to say length divided by equals and then 3.0. I'm then going to say snowflake side. So I'm recursively calling this function. And what I'm going to do is pass the length and the levels -1. Then what I'm going to do is turn the cursor. So I'm going to go left by 60 degrees. I'm then going to call snowflake side again. And I'll actually just paste this because we're going to do this 4 times. I'm going to go right by 120 degrees. I'm going to call snowflake side again. And then I'm going to go left by 60 degrees. And this is actually all we need to do to create a snowflake side. So let me just run this function and then I'll walk you through exactly how this works. So let's remove this tree for now. And let's remove this left. And let's just say snowflake side. And let's simply pass this a length. I guess we'll give it a length of maybe 200. And then for the levels, we'll just pass 2. All right, so let's run this. Okay, so let's have a look at this alongside the code just to see exactly what goes on here. So we start in our very first recursive call by dividing the length by 3. Then we see this recursive call, snowflake side. So what we do is we pass the length, which is now divided by 3, and levels -1. So now we come back up here, and at this point in time, the length is equal to 3 times less whatever the original length was, and the levels is equal to 1 because originally levels was equal to 2. All right, we then divide the length by 3 again. We then call snowflake side. So now the length is even smaller. We've divided by 3 2 times. Now levels is equal to 0. So at this point, we see levels equal to 0, so we hit our base case. So we go forward by the length that we have, which at this point in time is going to be 1/9 of our total length. So you can see that's kind of this first line right here is because this first recursive call has now finished. All right, so now we are done all of those. So what happens is the last place to call this, we now return back to here, and now we turn left by 60 degrees. So we turn left by 60 degrees. At this point, when we're kind of at this next recursive call, our length has been divided by 9 because 3 2 times, and then we call snowflake side. So we turn left by 60 degrees, then we come back up to levels. Levels is now equal to 0. And so what that means is we're in our base case. So we go forward and we draw this kind of line right here. Okay, so now we finish this recursive call. So we go and we see right 120. So we turn right by 120 degrees, and then we call snowflake side again. Now what happens is, well, levels is equal to 0 because levels was equal to 1. Now it's equal to 0. So we're now in our base case, we go down. Okay, then what we do is this recursive call is finished. So we go left by 60 degrees. So that kind of allows us to turn in this direction. We call snowflake side, and obviously levels is equal to 0. So we go forward. All right, so now we've kind of finished these 4 lines right here. So this first kind of triangle that's drawn with the 2 lines on the side, that's done. All right, so we've now finished this entire first call here. So line 32, that's done. So now we're back at kind of this original top level call to this function. And now what we're doing is we're turning left by 60, and then we're calling snowflake side. This time we're going to be passing levels equal to 1, not 0, because remember we're at the top level call. So levels is equal to 2. We subtract 1 from it at the function call. So we turn left by 60. That gives us this kind of angle right here. Hopefully you guys can see my mouse. And now we call snowflake sides. So we call snowflake sides, levels is equal to 1, we're on the base case, and so now we repeat this entire process again. And that's what then allows us to draw this line, this line, this line, this line. Notice that this right here, it's really hard to show you this, but you could see my mouse kind of going over this line. That's the same as this. So really all we're doing is combining this one kind of very standard pattern, which is that triangle with the 2 lines together. We're just combining that at a bunch of different angles such that it creates this kind of pattern. So I think I'm going to stop explaining it there because it's just really difficult to explain the recursive calls. I'm sure I'm confusing a lot of you guys, but now we know how to do one side. So now we know how to do one side, we need to figure out how we can combine the sides. But I'm just going to show you what happens if I make this depth equal to like 4, for example. So if I do this, like notice how small this gets and how advanced this is going to look. Obviously, as you increase the depth, it exponentially is going to have more and more lines and stuff that's going on. Just want to show you that. Okay, so now that we've done one side, as I was saying, we need to do all of it. So how do we do all of it? Well, we just need to draw 3 sides and connect them together. But I don't want to keep it super simple and just do 3 sides. I want to show you how we can do any number of odd numbered sides. Okay, so for this function, what I want to take, and I just want to look at my cheat sheet here, is the sides and the length for the snowflake that I want to create. And what I'm going to do is say for underscore in range. the number of sides that we pass, what I want to do is draw a snowflake side. And what am I going to pass the snowflake side? I'm going to pass my length, and I'm going to pass the number of sides that I have as the number of levels that I want to draw for my snowflake side. Then what I'm going to do is I'm going to turn right by, and this is going to be 360 divided by the number of sides. So what this is going to do is, I mean, I could run this and show it to you, but what this is going to do is draw the number of sides that we pass, and it's going to kind of rotate where the next side is drawn based on how many sides that we have. So in a circle, we have how many degrees? We have 360 degrees, which means if we want to have these sides connected all the way around, we need to angle them at whatever 360 divided by the number of sides that we have is. So I'll show you how this works with 3 sides. So rather than doing snowflake side, let's do create underscore snowflake. We're going to pass for the sides 3, and we'll pass for the length 200. And yeah, okay, that works. So let's just run this and look at what we get here. So we do one side, that's one side. We just did a second side, and now we're doing a third side right there. And for me to actually show you better when or where the sides are created, what I will do here is show you how we can change the color. So I'm just going to do this quickly because it's more for illustration here, but let's say green, blue, and yellow. Okay, and we're just going to say color is equal to colors at I+1. Okay, you don't have to understand what I just did here, but this is just going to do different colors. So let's run this, and you'll see where the different sides are. Oops, index out of range. Oh, crap. That's my bad. Sorry, it needs to be that. Okay. So now you can see these are our 3 sides. And notice that when it gets to this point, what actually happens is the turtle turns 120 degrees because we had 3 sides. So 360 over 3 is 120, draws the next side, turns 120 degrees again, then draws the other side. Now let's see what happens if we draw 4 sides. So if I draw 4 sides, I'm actually nervous to see if this is going to work or not because I haven't tried 4 sides yet. First of all, this is going to take a second, so once this is done, I'll be right back. All right, so I decided to change something to make sure this worked, but you can see that we've drawn this with 4 sides. I just added another color, which was orange, but this works with 4 sides. And if you go with 5, it's going to work as well. The way that I've kind of programmed this out, it's dynamic, so you can just change the number of sides, and well, that will change the shape of the snowflake. But that is how that works, right? Now here, rather than turning at 120 degrees, we're turning at 90 degrees, right? You can kind of see that there's this little interior square. If you were to draw a square inside of here, it'd be a perfect square because once we get here, we turn 90, 90, 90, and we're good. We have connected on all sides. So that is how you do the snowflake. That's pretty much all I needed to show you. Now, I mean, I could continue going through this and explain the recursion, but I think that's pretty much all you guys need to know. If you wanted to make multiple snowflakes, you could call this multiple times, but you would probably want to move the turtle to different positions. Now I'll just show you like how you do this. I think you can say move, or maybe it's to pause. There's a way to set the position. I think I have it. Oh, it's called go to. If you want to change the position of the turtle, what you can do is say go to XY, and then we'll actually go to that position. So I just wanted to show you that so you guys can see how you can draw multiple snowflakes, draw a snowflake, move the turtle, draw another one, move the turtle, draw another one, so on and so forth. All right, but that is it. I will leave a link to this code in the description. If I forget, someone please do remind me. But yeah, that's really how you can mess around with fractals and recursion in Python using the turtle module. I'll zoom out so you guys can read all of the code if you would like to do that. If you're not on a mobile device, I guess, because it's pretty hard to read that. And yeah, there you go. Now, as I was saying, this is kind of just scratching the surface of what's possible with this. You can imagine if I made this slightly random, if I didn't make everything, perfect angles, stuff would be off a little bit, but you'd be able to make some really interesting stuff. And if you were to add to this, maybe rather than doing 2 tree branches, you do 3, 4, 5 tree branches, you're going to see how much more advanced and interesting these shapes get. And you can just mess around with different angles, different sizes, and you'll see you get some really, really interesting pictures. All right, so with that said, I think I'm going to end the video here. Hope you guys enjoyed. If you did, make sure to leave a like, subscribe to the channel, and I will see you in another one.